Number 3. Assume the reaction represented by the following equation goes all the way to completion. Okay, now in reality, will this go all the way to completion? No. But for the sake of these calculations, we are going to assume that that is the case. So we have this balanced chemical equation, and if you're ever not sure if it is the balanced chemical equation and it's okay to use the coefficients here, check, right? Add them up. I got 2 nitrogens on this side, 2 nitrogens on this side. I have 6 hydrogens on this side and 6 hydrogens on this side. Okay, that's balanced. When in doubt, check. Part A. If 6 moles of H2 are consumed, and so we are actually stating that this much of H2 actually reacts, okay? If 6 moles of H2 are consumed, they are consumed, how many moles of NH3 are produced, right? So this is going to be a conversion of H2 into NH3, okay? So we're going to start with the moles of H2. We're going to convert out of moles of H2, moles of H2 into moles of NH3. Right? That's going to allow us to cancel out moles of H2, and we'll just use the mole ratio, right? Mole ratio of H2 to NH3, and our answer will be in terms of moles of NH3. So how much do we start with? 6. What's our mole ratio? 3 to 2. 6 times 2 is 12. Divided by 3 is 4. Right? The question gave us one significant figure, so let's report our answer with one significant figure. 4 moles. Part B. How many grams are in a sample of NH3 that contains 3.0 times 10 to the 23rd molecules? Oh my gosh, I have to relate molecules and grams. This is the worst. This is absolutely the worst. Oh, no, it's not. We have Avogadro's number. We're okay. All right, so we're going to start with 3.0 times 10 to the 23rd molecules of NH3. Right? We are going to convert out of molecules using Avogadro's number. For every 1 mole of NH3. Well, guess what? Now I've converted into moles, right? Those molecules will cancel. I'll be in moles. So moles of NH3. Now I can use molar mass to go into grams of NH3. Moles will cancel, so my final answer will have the units of grams of NH3, which is handy because the question is asking me for grams. So now let's plug in some numbers. 1 mole NH3. I know that nitrogen has a mass of 14.01. There are 3 hydrogens, so 3.03, so 4071. Nope, 4. Okay. So I had to calculate the molar mass of NH3, right? Because it's asking for a mass. I need to be able to convert from moles to mass. I use Avogadro's number to convert out of molecules into moles, right? And once I know moles, I can take the molar mass and convert into grams. Well, let's see what the calculator has to say about this. Now notice I'm only going to put in the coefficients. Okay, I'm not going to put in the exponents here because we are dividing a number that is times 10 to the 23rd by a number that is times 10 to the 23rd. So those are going to cancel, right? That's going to be nice. That's going to be nice and simple. Right? That's going to make it a little bit easy on us. So we're going to 3.0 times 1 times 17.04, right? That's the molar mass of ammonia that we just generated, divided by 6.022 divided by 1, and the necessary, but just for completeness. And we end up with a big old long number. But the question is, how many significant figures should I report my answer in terms of? I mean, look at that. That's not the number I'm supposed to report. I look at the question. I'm given a number with 2 significant figures. And so my answer should be reported with 2 significant figures. So I should report to right there. Well, what does the number right behind it say? Round it up. So I'm going to report 8.5 grams. 8.5 grams of NH3 are going to be found in a sample of 3.0 times 10 to the 23rd molecules of NH3. Then part C, if 0.1 moles, right? That's a little bit on the small side also, 1 significant figure. If 0.1 moles of N2 combine with H2, what must be true about the quantity of H2 for N2 to be the limiting reactant? All right, let's take some time to decode this. Let's make sure we know what's being said, right? The information that we can get out of the prompt so that we know exactly what we're being asked to do here. So we need, first and foremost, N2 to be the limiting reactant. What must be true about the quantity of H2 for N2 to be the limiting reactant? So we have to have N2 be the limiting reactant. Okay? Now, what do we know about limiting reactants? Let's think back to our example of musical chairs. The limiting reactant will be completely consumed. In musical chairs, the limiting reactant is the chairs. At the end of a round, when the music stops, all of the chairs disappear, right? They get used up. They're all gone. They all got butts in them. And so the chairs, the limiting factor, are completely consumed. And so what we know here is in order for N2 to be the limiting reactant, as is asked for by the question, all of N2 must be consumed. That is one of the key characteristics of a limiting reactant. Now the first part of the prompt says if 0.1 moles of N2 combine, right? And so we're stating that 0.1 moles of N2 have to be consumed. Well, we need the N2 to be the limiting reactant, so that must mean that all of this reacts. So let's continue to decode this question. What must be true about the quantity of H2 in order for, again, N2 to be the limiting reactant? What does it mean to be the limiting reactant? All of U reacts. So essentially we're being asked how much H2 is required to react with 0.1 moles of N2. Well, looking at this equation, we have a 1 to 3 ratio. We have a 1 to 3 ratio. Okay? So if we have 0.1 moles of N2, how much H2 do we need to react with that? Well, I use my mole ratio of N2 to H2, right? So I have 1 to 3, 1 to 3 moles of N2 cancel, and I end up with 0.3. I can even do that in my head. So what I can tell from this stoichiometric calculation using the mole ratio is that in order to completely react 0.1 moles of N2, which is what the question is asking me to do, right? This is what I have to do. I have to completely react all of this. Why do I have to completely react all of this? Because it needs to be the limiting reactant, okay? But how much H2 do I need to react all of this? I need 0.3 moles of H2.